An enchanting story.
Be prepared.
They're going to be looking for innovative people. And what better way to do that than to train yourself to be an innovator?
They shared an extraordinary adventure.
Hi, this is Law's group. They're gonna launch.
Dumpster digging.
Yeah.
Okay. Have fun.
Okay, so today we just moved wood all day.
And Nadine and I trashed the dumpster while Law took it on the pile.
Today we kind of finalized our design, sort of figured out what we wanted to do.
Yeah, we went through all our materials of wood and measured how long they were and how thick, etc.
We've got the two bottom ones for support that'll be hooked together with other ones, and then the two long ones that come up together, and then they meet, but they would probably be one of them on the inside of the thing and one of them on the outside of the thing, like the long board, so they'll need another smaller piece in between them, just to like hold it together so it doesn't fall apart.
Superfly.
Okay, so today we went shopping.
And we got mostly a bunch of screws and also 2 hooks and like lawn metal rod thing for the launch.
We'll connect, we'll draw through, and then pull it out to release. Oh! Oh, there's screws too.
Yep.
We got screws!
Hey,
Mine's Superfly.
Okay, so today we planned out some of the stuff from our video, for our final video, and we looked up the physics behind our catapult. If the faster it goes, the farther it'll
Neither
go.
velocity.
So if it is heavier, so we just have to make sure that it's heavier.
Yeah, but we could probably explain like how like we're gonna have like the angle up and it's gonna like stop right here.
So today we just kept building.
And building away.
Go! Ready? 3, 2, 1.
Oh yeah, baby! Our overall catapult consists of 2x4 wood screws, and a PVC pipe. In total, we spent $33.01. Throughout researching, we agreed that this was a more effective design because of how simply it was portrayed. The PVC pipe was strong enough to carry the weight of the 4 concretes. We also designed this catapult on AutoCAD to give us a good visual of how it will look. Throughout this main progress of building this catapult, our 3 main goals was to make sure the catapult was lightweighted, it was cost-effective, and it was unique.
The first day that we tested our catapult was the first test day that was given to us. We wanted to ensure that our catapult actually threw and make any improvements that we could to our design. When we first tested our catapult, it did not shoot, and that was because the weight was too close to the fulcrum, so we needed to move it further back. And we were also thinking maybe there wasn't enough weight. So to improve that, we added another piece of wood to the end of our lever, perpendicular, so that we could rest the cinder blocks on it and throw. This allowed the weight to be closer or further away from the fulcrum and make it able to actually throw. We also added 2 more cinder blocks to the end for our final throw to make it a total of 4 instead of 2, so the extra weight could make it throw faster and hopefully farther. With the added weight and the blocks moved back, our catapult was able to throw once we tested it. The improvements we did make before we tested our catapult were making the arm shorter so that when the cinder blocks were able to make it all the way vertical to the ground and make our catapult go as far as it could before it would throw the jug of water. And we readjusted our frame a little bit so that the 2 sides were even to each other and not off kilter.
The catapult operates under the physics of a lever of rotating amount of fulcrum and the counterweight at the other end of the object being thrown. So in our case, the fulcrum was the hole through the PVC pipe that the PVC pipe went through. So we had a downward force applied by these cinder blocks, which sent the other end upwards. So once the cinder blocks hit the ground, the lever would stop moving, but our object on the end, the gallon of water, would keep going at the angle it stopped. So this is why we had our end with cinder blocks as short as it was, so that it would be somewhere between those two. But unfortunately, the panel holding the gallon at the end failed, so it either wasn't going fast enough, or it was going at an even higher angle than it should have been.
Hello, Hamline Engineering FYSEM. We are Team
N.
J.
L.
And we want to wish you a Merry Christmas. Yay!
Merry Christmas.
Happy holidays.
And thank you to Superfly, Emily, and Lucy for making this a wonderful FYSEM